Hi, I'm Anna Tapper, and welcome to this bite-sized session on identifying misconceptions in maths and how to address them. This is part of the spring term CPD for 2023. Let's start by establishing a shared understanding of what a misconception is. A misconception is an understanding that leads to a systematic pattern of errors. Often misconceptions are formed when knowledge has been applied outside of the context in which it's useful. For example, pupils might state that multiplication makes an answer bigger and division makes an answer smaller. Well, that concept only applies to positive whole numbers greater than 1. However, when subsequent mathematical concepts are introduced, for example, working with numbers less than or equal to 1, such as fractions, decimals, percentages, and negative numbers, this conception, extended beyond its useful context, becomes a misconception. It's important that misconceptions are uncovered and addressed rather than sidestepped or ignored. Pupils will often defend their own misconceptions, especially if they're based on sound, albeit limited, ideas. In this situation, teachers could think about how a misconception might have arisen and explore with pupils that partial truth that it's built on and the circumstances where it no longer applies. Counterexamples can be effective in challenging pupils' belief in a misconception. However, pupils may need time and teacher support to develop richer and more robust ideas. Knowledge of the common errors and misconceptions in mathematics can be invaluable when designing and responding to assessment, as well as for predicting the difficulties learners are likely to encounter in advance. Teachers with knowledge of common misconceptions can plan lessons to address them before they arise, such as by comparing examples to non-examples when teaching new concepts. A non-example is something that is not an example of the concept. Based on the meta-analysis of evidence in the guidance report, Improving Mathematics in Key Stage 2 and 3, the EEF produced a guidance for teachers on how to identify and address misconceptions. The REACT framework gives teachers a structure to their planning when considering misconceptions. Pause the video here and take the time to reflect, and if with your colleagues, discuss this structured approach. Is this part of your normal practice already? Then take an area of learning and apply the REACT framework to your planning. In the R of the REACT acronym, the EEF suggests researching common misconceptions. For schools following mathematics mastery or white rose, there are already places you can go to identify these. In mathematics mastery, the unit tutorial video identifies as part of the key messages the common misconceptions to look out for. These are also identified in the unit narrative, which draws your attention to the areas to consider before teaching the unit. Videos to model conceptual thinking, examples and non-examples, and common errors and misconceptions. For those schools following White Rose, the notes and guidance section identifies things to look out for, which includes misconceptions. The key questions also act as prompts to support this identification too. In the T of the REACT acronym, the EEF suggests using diagnostic multiple choice questions. Diagnostic questions are a quick and effective way to identify and then address pupil misconceptions. The most effective way to use these is through whole class participation, which allows you to immediately assess understanding and give relevant feedback. So either using mini whiteboards or through a program such as Socrative on iPads. Craig Barton has worked with both Mathematics Mastery and White Rose to create diagnostic questions for each unit of learning. Mathematics Mastery provide pre-unit questions, which can be used to assess pupils' prior learning. You'll find them in the teaching overview for each unit. Here you can see a Year 3 fractions unit, and these questions are designed to address concepts taught in Year 1 and 2, to identify the potential misconceptions and give you the response signposts and related booster activities. The post-unit quizzes are designed to address any potential misconceptions from the current year group and unit. In this case, year 3 fractions. Mathematics Mastery have also provided the response signposts and related booster activities here too. In White Rose, you'll need to access questions from the Diagnostic Questions website. I'm going to walk you through it now, and mathematics mastery quizzes are also held on this website. So this is a Diagnostic Questions website designed by Craig Barton. You can find it through diagnosticquestions.com. It's a free website, but you will need to sign up to it. I can show you then, just sign in. On the homepage, you can add a class. So if you want to add all of your pupils to this website, you can do, and then they're able to access it through their devices, both in class or at home, and you can see their responses. But you don't have to do that. There are other ways in which you can still use diagnostic questions without setting it up on iPads. So on the side here, the useful actions, you can see that it offers you the opportunity to create a question, to build and assign a quiz, but the one that we're most interested in today is to view a quiz collection, because these have already been made for you. You can see the mathematics mastery quizzes are held on here, as well as in the My Mastery space, but we're going to look at White Rose today. The White Rose collections are for pupils in year 1 up to 6 and beyond. And each quiz is linked to the blocks of learning. You can see that there are 2 quizzes for each area of learning. There's no difference between those quizzes, so it's not that one is easier than the other, it's just 2 sets of questions. So we're going to look at year 3 today, because we did so with Maths Mastery, and we're going to scroll through and look for fractions. So I'm going to look at comparing and ordering unit fractions and fractions with the same denominators. And I'm going to choose quiz 1 for no reason. So I've had a look at quiz 1. There are 10 questions with each quiz. Before I'd use this with the class, I'd be looking so I know what's coming up and what questions they're asking. And I can work through from question 1 to 10 and ask the children to do so on devices, or I can snip the questions, put them on into my slides, and get the children to show me a response of A, B, C, or D as their answer. The great thing about diagnostic questions is that it's multiple choice, so every child can give an answer, and it's very low stakes. If you're using it online, they can click A, B, C, or D, but they have to give an explanation. Or they can just click, I'm just guessing. They won't be able to move on until the next question until they've done that. But for what I want to use today, I'm looking at this question. I'm thinking most of the children in my class will be able to understand it. So that's not going to help me identify any misconceptions. So here I'm going to go to Insights. The Insights button tells me which question the majority of children found most difficult. Here I can see that it's question 5. If I wanted to only use a couple of questions, I'd be thinking about these are the ones I'm going to snip and put into my slides. That's question 5, question 6, and question 3, because they're the ones most likely to uncover the misconceptions. So let's click on this one. I can snip this question, put it into my slides. The children can answer on whiteboards or by showing me on their fingers. And here underneath, Craig Barton's given some explanations about why pupils may have given these answers. So A, perhaps the student just guessed and would benefit from revisiting the topic. B, this piece of paper would be longest, as it would be 8 times as long. So if they've answered B, they've got that correct. C, the student may have just guessed and they may benefit from revising. D, the student may have picked the largest fraction, but in this case, we want the smallest. So the strip of paper which is longest does not mean the largest fraction. And that is a misconception that you might need to unpick a little bit further. So what I'd like you to do now, I'm going to show you how we get back to our quiz collections. Just going to get back through these. I'm sure there's a shortcut. So we go back to our quiz collection. I'd like you to register with diagnostic questions if you're White Rose, or look on the My Mastery website for the diagnostic questions there, and take some time to look through the questions for your current unit that you're teaching and the one that's coming up. How can you use these at the end of those areas of learning to help you identify the misconceptions that children hold, and how can you address those, plan to address those in your lessons? Finally, I'd like to summarise how you can address misconceptions. These recommendations come from the EEF guidance report and are explicit within the REACT framework. Consider how you can use them within your own classroom.